Hello everyone. Today's lesson is going to be about determinants and the area of a triangle using matrices. So the determinant is a number which can be calculated from a square matrix. Okay, so real quick, what is a square matrix? Think about a square. It has four equal sides. So if I want a square matrix, I want the rows to equal the number of columns. So I can have a 1 by 1, a 2 by 2, a 3 by 3, and so forth. Okay, and then the determinant has a couple of different notations. You can see DET with parentheses and the name of the matrix, DET of the matrix, so the A, or you can just see something that looks like absolute value bars. If you see that notation and it just says evaluate, then that means to actually find the determinant. And you are going to learn how to do the determinant both by hand as well as with a graphing calculator. So determinants can be used in vector geometry by, if we have a 2 by 2, we can get the area of a parallelogram. What we are going to do is the same type of thing, but we're going to create a 3 by 3 using the 3 points from a triangle, and we'll do 1/2 of the determinant to give us half of the parallelogram, which would give us the area of a triangle. And you always want to make sure, in this case, that you do the absolute value of the determinant. And the reason you want to do the absolute value is because area cannot be negative. If you get into some higher level mathematics classes and actually into encoding, you'll use the linear algebra. We'll use the determinant and the square matrix, and it encodes properties for transformations and such. I'll let the other professors dig deeper into that. So the determinant of a 2 by 2 matrix, again, these are the three different notations. They all mean the same thing. DET of A, determinant of the actual matrix, or those absolute value bars, that's what it looks like. So in order to determine the determinant of a 2 by 2, you multiply the diagonals and then you subtract their product. Okay, so I'm going to multiply the diagonals that fall down and then subtract the diagonals that go up. You're always going to start in row 1, column 1 and go down to the far right corner, and then whichever, depending on how many rows you have, you'll always start in that bottom row left column and then do the diagonals up. So first example. All right, example 1, find the determinant of A. So I can have the determinant of A, or I could just see these absolute value bars of the actual matrix. That's what they look like. Okay, again, that means to find the determinant. Just depends on how it's written for you. And our directions were to take A times D, so the down diagonals, multiply those, and then subtract the up diagonals, their product, 4 multiplied by -2. So 3 times 3 is 1, and a -4 times a -2 is a +8. So the determinant of A equals 11. That's it. That's all there is to it. In our second example, we are going to evaluate and find the determinant of Z. So our determinant of Z will equal, multiply the down diagonals, 11 by 2, and then subtract the product of the up diagonals, -3 times -5. So 11 times 2 is 22, minus -3 times -5 is a +15. So the determinant of Z is equal to 7. That's it, piece of cake. All right, so when we're dealing with larger matrices, 3 by 3s and 4 by 4s and so forth, there's a little bit more work. You'll notice that we've left out the letter I in this example just to make sure we don't make any silly mistakes. So just kind of follow through what I'm doing, and then we'll get to trying some with actual numbers that might help a little bit better. So in our determinant, we've got determinant of A, determinant of the matrix, or those absolute value bars. You'll notice that we are still multiplying the down diagonals, then we're finding the sum of all three of those, and then subtracting, multiplying each of the up diagonals, finding their individual products, and adding them as well. So downers minus uppers, down diagonals minus the up diagonals. These have all the letters that that you would use, and I'll show you a way that we can do this to make a little bit more sense. So what we're going to do, this last note at the bottom, in order to get each of the variables included, what I want to do is actually recopy column 1 and column 2 on the outside of the matrix. That is going to help us get the down diagonals, all three of them, AEJ, BFG, and CDH. I need all three full diagonals to be multiplied, the elements, and then add them all together. Then we'll subtract. Again, we're still going to do the up diagonals. The bottom left corner, that bottom row, GEC, that is a full diagonal, but because I've added that first column again, now I have HFA, and I know I have it written differently, multiplication, the order doesn't matter, and then the last up diagonal is JDB. Okay, so those are the down diagonals minus the up diagonals. And we're going to practice it by hand. Don't stress. So here we go, our first one by hand. Find the determinant of matrix A. So our first step is to rewrite column 1 and 2 on the outside. Okay, so column 1 is 2, 3, 6, and column 2 is 4, 5, -3. We are now going to multiply the down diagonals, each of them individually. We're going to put them in parentheses, minus, and then our upper diagonals. Okay, so my down diagonals are 2 times 5 times 1. So you can write all that out, or you can just write 10, minus 4 times 2 times 6. 4 times 2 is 8. 8 times 6 is 48. Or excuse me, plus, my bad. And then plus the next set, -1 times 3 times -3. That would give me a +9. Okay, let me actually erase all those so you guys can see that a little bit better. Sorry, I didn't realize I was writing in highlighter. So that was 10, or 2 times 5 times 1 for the first set of downers, plus 4 times 2 times 6 for the next set, which is 48, plus, and then our last diagonals, -1 times 3 times -3, which is +9. Okay, we'll come back and do the sums of these in just a moment. Now we're going to do the upwards diagonals. So I'm going to do, starting in the bottom left corner, 6 times 5 times -1. And that will give me, let's see, 6 times 5 times -1, which will give me -30, plus, do the next set, -3 times 2 times 2. So -3 times 2 is -6 times 2 is -12. And then our last set of up diagonals are 1 times 3 times 4. And 1 times 3 times 4 gives me +12. So now we are going to simplify. My down diagonals have a sum of 58 and 9. So 58 and 9 would give me 67, minus, and our other diagonals, -30 minus 12 plus 12. So those guys eliminate, just giving me minus -30. So the determinant of this 3 by 3 is 67 minus -30, which is 97. All right, what'd you think? Too bad? I didn't think it was too bad. A little bit of practice, take some time. Okay, our next example, example 2, find the determinant of matrix Z. Again, we're still going to recopy the column 1 and column 2 info on the outside so we can get those full diagonals. So I need to rewrite a -2, a 1, followed by an 8, and then a 3, a 0, and a -1. Okay, so we are going to do the downward diagonals first, minus the upper diagonals next. So my down diagonals, whoopsies, I forgot to highlight. I love when I have zeros in here. It makes it so much easier to multiply. -2 times 0 times 6. Anytime I see a 0, I just write a big fat 0. Cool. 3 times 5 times 8. So 8 times 5 is 40. 40 times 3 would be 120 plus. And then our last one, 4 times 1 is 4, times a -1 is a -4. Okay, if you want, you can go ahead and simplify that. 0 plus 120 minus 4 is 116 minus. All right, let's do our upward diagonals. 8 times 0 times 4, thank goodness, is another 0. -1 times 5 times a -2 will be a +10. And 6 times 1 is 6 times 3 is a +18. So I have 0 plus 10, which is 10, plus 18 is 28. And when you subtract, you determine, that the value, why am I writing a 2 there, is actually 88. So the determinant of matrix Z is 88. There you go. All right, so now we're on to the application. You've got to remember a couple of things from geometry. The area of a triangle is 1/2 the base times the height. Okay, so when we find the area of the entire rectangle it would be, then we must make sure that we multiply by 1/2. So I'm going to list my ordered pairs that I have for my triangle. 1, 2. This one is 1, 2, 3, -4, +4. And then our third point is at -3, -2. So I'm going to list each of these in a matrix. 1, 2, -4, 4, and -3, -2. Now the problem is, in order to find the determinant, which we're going to use, the area of the triangle is going to be 1/2 of the determinant of the matrix. I need a square matrix. So I need to fill in each of these columns, or each of these elements in the last column. To make it a 3 by 3, fill them in with a 1. We will then recopy the first row and the second row outside of the matrix so that I can do the same downers minus the uppers, the down diagonals minus the up diagonals. Okay, that will give us our determinant. We're going to find the determinant of all of that mess. So 1 times 4 times 1 is 4, plus 2 times 1 times -3 is a -6, plus 1 times -4 times -2 is a +8. So those are my downers. Minus, do my up diagonals. -3 times 4 times 1 is -12. -2 times 1 times 1 is -2. And 1 times -4 times -2 is -8. Okay, so our determinant in this case simplifies to be, let's see, 4 minus 6 is -2, plus 8 is 6, minus 12, -12, -2 is -14, and then minus 22. So we get 28 as the determinant. But remember, we have to do 1/2 of that value because it's 1/2 of the square. So half of 28 gives us a +14, and that would be units squared. That is the area of this triangle. Okay. If we were to happen to get a -28 as the determinant, then we would have to take the absolute value of it and then multiply by 1/2. You should still end up with a positive value always for area. All right, so you can practice any of the worksheets A, B, or C for any of the operations practice, and worksheet D is strictly just determinants and area of a triangle. And you have your first quiz at the end of this week, the next quiz the next week, and then your test the following week.